I saw the data this morning. I think a lot of people saw the headlines, the 10-fold improvement in the trajectory analysis from the ExoMars Trace gas orbiter, and they just scrolled past it. They think, okay, the scientists did the math, the line on the graph is thinner, moving on. But that is a fundamental misunderstanding of what just happened. When you narrow the probability cone of an object moving at 68 kilometers per second by an order of magnitude, and the object stays on a trajectory that defies standard Keplerian mechanics, you stop sleeping. You have to. See, usually when we track these things, near-Earth objects, comets, whatever the error bars are, your friends, the uncertainty allows you to say, well, maybe it's just outgassing unevenly, or maybe it's tumbling in a weird way. Uncertainty creates a fog where you can hide conventional explanations. But the data that came down from the TGO and the updated parallax from the Atlas stations in Chile and South Africa, it cleared the fog. The trajectory didn't just sharpen, it hardened. And it hardened into a path that, quite frankly, makes the hair on the back of my neck stand up. We are looking at an eccentricity of roughly 6.14. That is, it's absurd. It's not just hyperbolic, it's aggressively unbound. To give you a sense of scale, Oumuamua was around 1.2. Borisov was about 3.4. This thing, 3I Atlas, is coming in with so much kinetic energy that it laughs at the sun's gravity well. But that's not the part that has the astrophysicists freaking out. High speed is just high speed. It's the delta, it's the change. The narrowing of the trajectory data confirmed the non-gravitational acceleration, the NGA. Now, usually NGA is boring. It's the rocket effect. A comet heats up, ice turns to gas, it shoots out a jet, and the rock gets a little push. Action, reaction, Newtonian physics. But for that to happen, you need mass loss. You need to see the stuff leaving. We have looked. We have looked with Hubble. We have looked with Webb. We see some hydroxyl, sure. We see some blue spectral lines. But we do not see the massive plumes of dust and water vapor required to push a rock this size, this fast, with this level of precision. The math implies a continuous, low-thrust acceleration that correlates perfectly with its orientation to the sunday. It's behaving less like a crumbling snowball and more like a solar sail or a guided craft. And now that the trajectory uncertainty is gone, we can't dismiss the acceleration as a measurement error. It's real, it's happening, and it's correcting its course. When you look at the universe through the lens of physics, you have to strip away what you want to be true and look at what is actually true. Entropy is the rule. Disorder is the rule. Rocks tumble. They don't stabilize. They don't execute smooth inclination changes that optimize for planetary observation. The probability of a natural object having this specific set of vector parameters, high eccentricity, high inclination, anomalous acceleration, without proportional mass loss is vanishingly small. It's not zero. But it's so close to zero that betting on it being a rock is starting to look like the irrational bet. 2, the physics of impossible momentum. Let's get into the first principles here, because I think the media does a terrible job of explaining the orbital mechanics. They just say, it's fast, but fast is relative. If you're in a Ferrari, 200 miles an hour is fast. If you're in orbit, 17,000 miles an hour is standing still. This object, 3I, entered our system at a hyperbolic excess velocity, $v, empty dollar, of around 60 kilometers per second. That is the speed it had when it was effectively at infinity before the sun even started pulling on it. That's the baseline. That tells us it didn't come from our Oort cloud. It didn't come from our neighborhood. It came from deep, deep interstellar space. Now, as it fell down the gravity well towards perihelion in October, it picked up speed, obviously. Conservation of energy. Potential turns into kinetic $E equals K plus U dollar. It maxed out at something like 68 kilometers per second relative to the Sunday. But here is the kicker. The energy equation doesn't balance if you just use gravity. If you model this as a pure ballistic trajectory, just a rock falling through a vacuum, affected by gravity, the position we see it in today, November 18th, should be different. It should be thousands of kilometers to the left relative to the ecliptic plane of where it actually is. The 10x narrowing I mentioned, that was us confirming that the drift wasn't an error. The object is intentionally or at least physically deviating from a ballistic arc. Let's talk about the force required to do that. $F equals ma dollar. Simple, right? We estimate the diameter is somewhere between 400 meters and maybe a few kilometers. Let's be conservative and say it's 500 meters across. If it's made of rock, that's millions of tons of mass. To shift a mass that large, moving that fast, by even a fraction of a degree, requires a tremendous amount of energy. If it's natural, that energy comes from the sun boiling off its surface. But the spectral analysis is weird. It's blue. Comets are usually reddish or dirty white because of tholins and dust. This thing is blue, and we're detecting nickel, not iron, nickel. Why is that weird? Because in the periodic table in the cosmos, iron and nickel usually hang out together. Iron is actually more common in stellar nucleosynthesis. To see a plume that is nickel-rich but iron-poor is. It's like walking into a forest and seeing a tree made of pure aluminum. Nature doesn't usually refine metals like that. We do. Industrial processes do. So you have a blue object, possibly metallic or covered in some exotic ice that reflects blue, accelerating without enough visible propellant, and is dumping refined nickel into the void. If I pitch this as a sci-fi movie script, they'd say it's too on the nose. But this is real life. This is the data on the screens right now. And the scary part about the momentum isn't just that it has it, it's that it's keeping it. The drag from the solar wind, the radiation pressure. Usually these things act as a headwind or a chaotic force. But 3I seems to be surfing it. It's using the radiation pressure. If you were designing an interstellar probe and you wanted to brake or perform a gravity assist without burning fuel, what would you do? You'd use a light sail. You'd use the momentum of photons hitting a reflective surface to transfer momentum. The acceleration we are seeing matches the profile of a light sail with a mass-to-area ratio that is remarkably engineered. It's too light to be a solid rock. It has to be hollow or a sheet. That's the freak out, is the density calculation. If the geometry is 500 meters, but the acceleration is x, then the mass must be y. If y is too low for a solid rock, then it's not a solid rock. It's a shell, a structure. 3, the impact probability and the great filter. I spent a lot of time talking about the Fermi paradox. Where are the aliens? The universe is 13.8 billion years old. Earth is 4.5 billion. That's a huge gap. A civilization that emerged just 1 million years before us, a blink of an eye in cosmic time, should have colonized the galaxy by now. We should see Dyson spheres. We should see traffic, artificial structures encasing stars, evidence of engineering at scales beyond imagination. But we see silence. That silence is deafening. It is not merely absence of signal. It is the echo of questions we have yet to answer. What does it mean to be alone? Or, perhaps more terrifyingly, what does it mean to be discovered only once we reach a certain level of visibility? The universe, it seems, is quiet, patient, and indifferent. Yet it may also be strategic. The great filter, the concept that civilizations fail to survive, the steps needed to become interstellar, is one of the most sobering interpretations of that silence. Maybe intelligent species inevitably destroy themselves before escaping their planetary cradle. Maybe the leap from single-planet life to multiplanetary existence is too arduous. Or maybe, and this is the darker possibility, they are quiet because it is dangerous to be otherwise. This is the premise of the dark forest theory. Civilizations are silent because survival depends on being undetectable. Every signal sent is a potential invitation to annihilation. Every attempt at communication is a gamble with existence itself. And now 3I, Atlas, appears. It's not hitting Earth. Its closest approach in December is going to be about 1.8 astronomical units further than the Sun, and certainly no risk of an impact. It won't end life here. It won't wipe out the dinosaurs. It won't leave a crater large enough to rearrange continents. Yet its presence is an existential threat in a different sense. This is a threat of information, of knowledge, of understanding that surpasses the scale of our civilization. Because if this object is a probe, an artifact of alien engineering, the silence is broken. We have been quietly orbiting our sun, managing our petty disputes, crafting our fragile societies, while the universe continued its work without concern for our narratives. Now that silence has been pierced, and we don't know who or what broke it. We don't know if it's benevolent, indifferent, or hostile. And that uncertainty is profound. Imagine for a moment being an uncontacted tribe in the Amazon. You've lived your entire life unaware of the outside world. You have your customs, your rhythms, your intimate understanding of the forest, the river, the sky. Then, one day, a drone flies over your village. It doesn't attack. It doesn't land. It hovers, takes high-resolution photographs, perhaps samples smoke from your fire, and then disappears into the sky at a speed beyond comprehension. The drone itself may be harmless, but the civilization that built it, they hold the power to reshape your world in ways you cannot imagine. That is the position humanity occupies now. We are the tribe, and 3I, Atlas, is the drone. We can observe it, we can measure it, we can speculate about its origin, but we are profoundly vulnerable. Every insight is paired with the awareness of our fragility. Every calculation is accompanied by the knowledge that we are at the mercy of forces we are only beginning to perceive. The trajectory of 3I, Atlas, is what has scientists losing sleep. It implies targeting, not targeting for impact, but targeting for data. It passed close to Mars. Now it is passing Earth. It entered the solar system at an inclination that allowed it to scan the ecliptic plane, the path along which planets circle the sunday. If you were to run a simulation for optimal observation trajectory for solar system survey, the path looks uncannily like the one this object has taken. It's a remarkable coincidence, if it is a coincidence at all. But when the numbers grow so precise, one begins to doubt randomness. The universe allows chance, but not necessarily on the scale of precise, intelligent design. Something deliberate may be at work. Then there is the matter of the nickel. Why is it dumping nickel? Is it exhaust from a propulsion system, or a sign of internal repair, or is it something more? Could it be a marker, a subtle beacon left in the solar wind, a message that reads, "I was here, system inhabited, resources verified"? If that interpretation is even partially correct, then we are operating on a timeline far longer and far more consequential than any human strategy, policy, or planning horizon. We have been preoccupied with terrestrial concerns, with borders, economies, and ideologies, while a civilization, if civilization is indeed behind this, may be playing a four-dimensional chess game across light years and centuries. We are novices at the table. Every second we waste ignoring the implications is a second lost in learning the rules of the universe. This is why Mars is critical. This is why I push teams at Starbase, at every facility, to the edge of what is possible. Humanity is a single point of failure species. A single catastrophic event, a planetary impact, a nearby supernova, a rogue probe with destructive capacity could wipe out everything in an instant. If 3I, Atlas, had been just 10 degrees to the left, aimed directly at Earth, we would have had zero defense. 6 months of observation would have led to nothing but the slow certainty of annihilation. That proximity to disaster underscores the fragility of our civilization. It is an uncomfortable awareness, but necessary. Without acknowledging vulnerability, we cannot develop resilience. And yet, within that vulnerability lies opportunity. We are forced to accelerate. We are forced to think beyond the myopia of our daily concerns. To survive, we must master propulsion, energy systems, life support, radiation shielding, and orbital mechanics at scales never previously demanded. We must become interplanetary, not as a luxury, but as a necessity. Humanity must expand beyond the cradle of Earth, not for conquest, not for pride, but for survival. Our technological growth, our ability to cooperate on a planetary scale, our capacity to innovate, these are not abstract achievements. They are the difference between existence and oblivion. And 3I Atlas, whether probe, natural anomaly, or artifact, has become the mirror in which we confront that reality. The implications go further than mere survival. They force a reconsideration of intelligence itself. We have long assumed, sometimes arrogantly, that human cognition is the pinnacle, that our capacity for thought, communication, and engineering is unique in the cosmos. The detection of 3I, Atlas, forces the realization that intelligence may not only exist elsewhere, but may be capable of actions on scales incomprehensible to us. It forces humility. It forces recognition that our technological infancy is a liability. It forces an awareness of the responsibilities of power. If the builders of 3I, Atlas, exist, they are capable of observation, calculation, and execution across interstellar distances. Their patience spans centuries. Their strategies are incomprehensible. Our ability to survive or thrive may hinge on our capacity to learn and adapt at an unprecedented pace. Consider the philosophical ramifications. For millennia, humans have debated our uniqueness, our place in the cosmos, our purpose. Religion, philosophy, and science have all grappled with the same questions from different angles. Are we alone? Are we significant? Do our struggles matter in the grand scheme? 3I Atlas refuses to provide answers. Instead, it forces us to confront the questions directly. It demands a synthesis of ethics, technology, and imagination. It forces us to ask, how should a civilization behave when it knows it is being observed? How should we act when faced with an intelligence that may be far older, far more capable, far more patient than our own? These are not hypothetical musings. They are urgent considerations with real-world consequences for research priorities, international cooperation, and the very trajectory of humanity's survival strategy. The presence of 3I, Atlas, also amplifies the tension of time. The timeline of its passage is brief on a cosmic scale, but intense on a human one. Observations must be made quickly, calculations executed rapidly, theories tested with immediacy. There is no room for delay, indecision, or bureaucratic inertia. The pressure of opportunity compresses centuries of potential knowledge into months of action. Every observation, every data point, every measurement may carry significance far beyond what we can immediately interpret. The universe is speaking in a language we are only beginning to learn, and every second of delay risks misunderstanding or missing the message entirely. And the stakes are not abstract. Our civilization is fragile, beautiful, and precarious. Our species has achieved remarkable things: art, culture, science, philosophy, but we are still tethered to a single planet, dependent on a delicate ecosystem, a narrow range of conditions, and limited technology. The cosmos does not forgive unpreparedness. Catastrophic events, interstellar phenomena, and unknown civilizations are indifferent to our existence. The arrival or even the observation of 3I, Atlas forces recognition of this stark reality. Survival is contingent on action, not assumption. Mastery, not complacency. Awareness, not ignorance. There is fear, certainly, but there is also exhilaration. To witness the potential signs of intelligence beyond Earth is to encounter the universe at its most expansive and mysterious. The unknown is simultaneously a threat and an invitation. It demands courage, curiosity, ingenuity. It challenges assumptions, tests our resilience, and accelerates our evolution, not just technologically, but cognitively, socially, and ethically. Every calculation we make, every launch we attempt, every observation we record is a defiance of complacency. It is an assertion of humanity's capacity to exist meaningfully, even in a universe that may be indifferent, strategic, or hostile. Every act of exploration is a testament. Every observation of 3I, Atlas, every simulation run, every discussion among scientists and engineers, every mission planned for Mars is part of a continuum that stretches beyond individual lifetimes, beyond decades, beyond centuries. We are participants in a narrative that may be shaped by intelligences older than our species, observing, recording, calculating. We are both the subject and the agent of change. We are the tribe observing the drone, but we are also the tribe beginning to build the tools to move beyond mere survival. We are learning, adapting, and striving, compelled by circumstance and opportunity alike. And yet, there is humility in this striving. We are novices. We are fragile. We are unprepared in many ways. We have much to learn, much to develop, much to prove not just to ourselves, but to the universe. The arrival of 3I, Atlas, is a challenge, a test, a moment that compresses the enormity of cosmic history into the immediacy of human awareness. It is the reminder that survival, understanding, and progress are contingent on action, on courage, on rapid learning, and on the willingness to confront forces vastly larger than ourselves. It is a call to wakefulness, to awareness, to responsibility, and to ambition. And so we act, we observe, we calculate, we launch probes, we analyze trajectories, we refine instruments, we collaborate across borders and cultures. Every step is a statement. We exist, we strive, we attempt, we reach. And whether or not the builders of 3I Atlas are aware of us, whether or not they intended their passage to be noticed, the fact remains, we have been confronted with the extraordinary. And in that confrontation lies the potential for growth, for knowledge, for survival, for evolution. We cannot retreat into ignorance. We cannot rely on luck alone. The time to act is now. We have been given a glimpse, a hint, a contact, even if indirect, with something that may redefine our understanding of intelligence, technology, and survival. And that glimpse demands everything we can muster: intellect, courage, imagination, cooperation, resilience. We are called to rise to a new scale of thought and action, to become more than single planet dwellers, more than creatures of immediate concern, more than novices in the cosmic game. The drone has passed, the signal has been received, and the challenge is clear: adapt, survive, reach, and learn, or risk irrelevance, fragility, or destruction. The universe is vast, indifferent, precise, and unimaginably complex. Yet within that vastness, we have found a point of contact, a reason to accelerate, a reason to awaken. That point of contact is fragile, fleeting, and uncertain, but it is a beginning. And a beginning, even in uncertainty, is all we need to act. Every calculation, every observation, every mission, every effort to understand 3I Atlas is a step towards survival, toward comprehension, toward becoming the species capable of enduring, thriving, and reaching beyond the cradle of Earth. We are the tribe 3I. Atlas is the drone. And the universe is waiting for our response. It is indifferent, but it is real. It is patient, but it is precise. And in confronting it, we confront ourselves, our intelligence, our courage, our fragility, and our potential. This is the reality of being human in a cosmos that is alive with possibility, mystery, and challenge. We do not know what comes next. We may never know. But the attempt to understand, the attempt to survive, the attempt to reach, these are the acts that define us. And for that, we must act now, with urgency, with imagination, with cooperation, and with the courage to face what lies beyond our small, fragile world. 4, why the establishment is frozen. You'd think, with data this compelling, that NASA, ESA, the Chinese agencies, everyone would be mobilizing everything they have. And to be fair, they are pointing telescopes. The Deep Space Network is listening. But they are paralyzed by the giggle factor. In science, nobody wants to be the guy who says aliens and then turns out to be wrong. It destroys your career. So you have this massive institutional bias towards the null hypothesis. They will twist themselves into pretzels to explain this as a dark comet or a hydrogen iceberg or some other exotic natural phenomenon that we have never seen before, just to avoid saying the obvious. They are waiting for extraordinary evidence. But the trajectory narrowing is the extraordinary evidence. The non-gravitational acceleration is the evidence. The bureaucracy is designed to be slow. It's designed to write papers, peer review them, publish them in a year, and then maybe propose a mission that launches in 2035. We don't have 2035. The object is leaving. It's at perihelion plus a few weeks. It's on the outbound leg. Every second that ticks by, it gets fainter and further away. We need to be agile. We need to take risks. This is not the time for a committee meeting. This is the time for a scramble. I spoke to some people at the agency, good people, smart people, but they are terrified of the press release. They are terrified of panic. They think if they say, hey, this might be a probe, the stock market crashes or religions collapse. I think they underestimate people. I think people want to know the truth. I think the realization that we are not alone would be a unifying force. It would make our petty squabbles look ridiculous. But because they won't act, we have to. We can't just sit here and take pictures from the ground. Ground-based astronomy is limited by the atmosphere. Space-based telescopes like Hubble and Webb are great, but they can't touch it. They can't sample the plume. They can't see the surface texture. We need an intercept, and this is where the physics gets really brutal. 5, the interception plan, Starship, and the kinetic kick. Okay, let's talk engineering. How do you catch a bullet that is moving at 68 kilometers per second? Answer, you don't. You can't catch it. We can't match that speed. The fastest object we've ever built, the Parker Solar Probe, goes fast, but only because it's diving into the Sunday to match 3I Atlas's vector and speed on an outbound trajectory. We simply do not have the chemical energy. The rocket equation is a tyrant. $delta V equals I. SP.G0 C.line M. 0 divided by M F dollar. Even with Raptor 3 engines, even with Methalox, we can't carry enough fuel to accelerate a probe to 60 kilometers per second and stop alongside it. So, we don't stop, we do a flyby. A hypervelocity flyby. The window is closing, but we have Starships, we have the Super Heavy booster, we have the capacity to put 150 tons into low Earth orbit. Here is the rough concept we are working on right now. We strip a Starship down. No heat shield, no flaps, no life support, just tanks, engines, and a massive third stage, a kicker stage. Maybe a solid motor, maybe an ion drive for the long haul, but we probably need high thrust to get the intercept vector. We launch a swarm, not one probe, 10, 20, small, agile nanosats packed into a dispenser. We blast them out on a collision course with 3I. We aim for where it's going to be in 3 weeks. The closing speed will be insane. The relative velocity might be 40 or 50 kilometers per second. You have microseconds to take the picture. You have milliseconds to sample the dust. But here is the trick. We don't just want pictures. We want to know what it's made of. So we send a kinetic impactor. One of the probes is just a slug of tungsten. It hits the object, or tries to. If it hits and creates a crater, the other probes fly through the debris cloud. They taste the ejecta. Is it rock? Is it ice? Or do they find alloys? Do they find polymers? If it's a light sail, the impactor might punch right through it. That would be a data point too. We are crunching the numbers on the launch window. It's tight. We might have to launch from Boca Chica in a way that violates every FAA regulation on the books. We might have to dogleg over populated areas to get the inclination. But I think, given the stakes, we can get forgiveness. We have the hardware. The vehicles are sitting on the pad. It's just a matter of software and payload. We are 3D printing the dispenser brackets right now. The sensors are off-the-shelf components we use for Starlink satellites. This is the beauty of vertical integration. We don't need a 5-year procurement cycle. We just go to the warehouse, grab the parts, and weld them together. Because if we let this thing leave the solar system without a close-up, it will be the greatest failure in the history of human science. We will look back at 2025 and say, we had the rocket, we had the warning, and we stayed on the couch. I'm not going to let that happen. 6, the future of consciousness. Let's zoom out for a second. Why does this matter? Why am I freaking out? Why are the scientists who know what they're looking at losing their minds? Because it forces us to grow up. For all of human history, we have lived in a bubble. We thought we were the center of the drama. We thought the universe was made for us. Even when we learned about Copernicus and Darwin, we still felt special. We felt safe. There was a comforting narrative in thinking that while we were not at the center of everything, we were at least in control of our little corner. We had our planet, our sun, our seasons, our routines. Civilization evolved around that sense of security, that belief that the cosmos was a backdrop to our story. But 3I Atlas doesn't care about comfort. It doesn't care about narratives. It is raw evidence that the universe is doing its own thing, and we're barely scratching the surface of understanding it. 3I, a loss is a wake-up call. It tells us that the galaxy is busy. It tells us that we are effectively living in a grass hut next to a superhighway, and we just heard the first truck go by. And when I say superhighway, I mean something on an unimaginable scale, a celestial thoroughfare where cosmic bodies, intelligent or not, are moving with purposes we cannot yet fathom. This isn't a distant abstraction, it's a confrontation with reality. It is a demand for perspective. The trajectories, the speed, the shape, the inexplicable anti-tail, it all screams that we are spectators to something vastly more complex than anything humanity has yet encountered. If it is artificial, it means intelligence is possible elsewhere. That's not just a comforting thought. That's a paradigm shift. Intelligence, technology, innovation, the capacity to alter reality, all of these could exist in forms and degrees that stretch our imagination. It means civilizations might rise and survive long enough to navigate the void between stars, and that, strangely, is both humbling and inspiring. It gives me hope. It implies that the great filter, the hypothetical barrier that prevents civilizations from surviving long enough to become interstellar, is passable. It implies that the universe does not impose a limit on potential, only a challenge. And if others can pass that challenge, so can we. We can make it. But hope comes wrapped in urgency, because if intelligence exists out there, it means we have competition. It means we are not the apex predators of the Milky Way. We are the new kids. And the new kids need to get smart, fast. Evolution worked in our favor over millions of years to create consciousness capable of understanding the laws of physics, of developing tools and society. But evolution didn't prepare us for an encounter with something that might already be millions of years ahead. That encounter forces acceleration, a compression of timelines. We have to rethink our priorities, our capabilities, our very way of interacting with the universe. We need to become multiplanetary, not as a luxury, not as a fantasy, but as a survival imperative. Earth is a beautiful, fragile sphere, but it is a single point of failure. We have lived here for millennia as if permanence were guaranteed, but the cosmos has no such guarantees. Asteroids, supernovae, climate tipping points, pandemics, they are reminders that security is an illusion if concentrated in one spot. To thrive, we need redundancy. We need to back up the biosphere. We need to ensure that the story of life on Earth doesn't hinge on a single fragile thread. And while we are at it, we need to expand our consciousness. We need minds capable of perceiving and processing phenomena that today seem almost alien. Right now, we are like ants looking at a circuit board. We see shapes, patterns, movements, but we do not understand the function, the logic, the intention, if any, behind them. That gap is both terrifying and exhilarating. The narrowing of 3I, Atlas's trajectory, was the moment reality snapped into focus. It was the instant when cosmic indifference crystallized into mathematical precision. The universe does not negotiate. It does not care about our opinions or beliefs. It follows rules, laws, patterns. And to survive in such a universe, we must learn to master it. Physics is not optional. Engineering is not a hobby. Technology is not merely convenience, it is survival. The very existence of this object forces us to confront that fact. It forces us to think on scales of time, distance, and consequence that strain our comprehension. Every calculation, every observation, every attempt to understand its motion is a lesson in humility. And yet, in that humility lies the path forward. Because mastering physics and engineering is also mastery of possibility. We are going to launch. We are going to try to catch a glimpse of this thing. Maybe we fail. Maybe we miss. But the attempt, the sheer act of reaching out into the void is what makes us human. It is what differentiates us from the rocks and dust scattered across the solar system. The attempt embodies our curiosity, our audacity, our refusal to accept that the universe is unknowable. The attempt is the proof of life, the assertion that we exist, that we matter not in some cosmic sense dictated by the stars, but in the act of striving itself. And maybe, just maybe, someone or something is watching and will see that we did not hide, that we reached, that we tried. That is the essence of civilization. Not simply to survive, but to seek, to explore, to confront the unknown. We are living in a moment that is unprecedented in human history. The tools we have at our disposal, the telescopes, the satellites, the computational power allow us to detect and analyze objects at distances that would have seemed magical even a century ago. And yet, tools alone are not enough. We need imagination, creativity, and courage. We need the willingness to challenge assumptions, to question the comfortable story of our own centrality, to look at a strange object racing through our solar system and not dismiss it as a fluke, a mistake, or a mere curiosity. To take it seriously is to take ourselves seriously. To recognize that the universe is not a backdrop, but an active, dynamic, sometimes hostile arena. Every discovery like this is a mirror held up to us. It shows what we have accomplished, yes, but more importantly, it shows what we have not. Our societies, our governments, our cultures, they are still tethered to the immediacy of survival and short-term goals. But Three-Eyed Atlas asks us to think in cosmic time. It asks us to consider centuries, millennia, and beyond. It asks us to plan not just for the next decade, but for the next age of humanity. And it asks us to do so knowing that other intelligences may have already traversed those very paths, succeeded or failed, leaving traces we are only beginning to perceive. There is also a philosophical confrontation here. We have long debated our uniqueness, our purpose, our destiny. Religion, philosophy, science, they all grapple with the same questions in different ways. Are we special? Are we alone? Do we matter? The arrival, the detection, the study of Three-Eyed Atlas forces a synthesis of those debates. It does not answer the questions, but it makes them unavoidable. If intelligence exists elsewhere, our mythology of uniqueness is incomplete. If technology can survive the stars, our assumptions about fragility are challenged. And if the universe is indifferent, our morality, our cooperation, our shared effort, these are the only tools we have to carve meaning and purpose from the void. Imagine the ripple effect. Scientists across disciplines are talking in hushed tones. Engineers are calculating trajectories that could let us intercept or observe more closely. Philosophers are rethinking humanity's place in the grand order. Artists are finding inspiration in forms and movements that were previously unimaginable. Every sector of human endeavor is, in some sense, being pulled forward, accelerated by a single object that entered our solar system. That is the power of contact, direct or indirect. It is a call to action, a challenge, a spark that could ignite centuries of advancement in a matter of years. And we must be vigilant. Curiosity is essential, but so is caution. The cosmos does not reward recklessness. Every mission, every calculation, every decision carries stakes that are, quite literally, interstellar. Our understanding of propulsion, radiation, energy, and life support will be tested. Our ability to collaborate across nations, cultures, and institutions will be tested. And our willingness to accept the unknown, to confront uncertainty without fear, will be tested. The stakes are not merely survival, they are evolution, adaptation, and transformation. Three-Eyed Atlas may be a messenger, a probe, or a phenomenon beyond our current comprehension. Whatever it is a teacher, and we are students suddenly forced to learn faster than ever before. The implications extend beyond science and technology. They seep into our consciousness. They demand humility, resilience, imagination. They force us to think not in terms of immediate gratification, political gain, or economic profit, but in terms of legacy, continuity, and the enduring story of life itself. Every calculation, every observation, every theory we propose is a thread in a tapestry that extends far beyond us, beyond our planet, beyond our solar system. And yet, that tapestry is ours to weave. The cosmos presents the raw materials. We provide the narrative, the attempt, the striving. And consider the emotional dimension. There is fear, yes, existential fear, the kind that keeps you awake at night. But there is also exhilaration, an unparalleled thrill to realize that the universe is not empty, not static, not indifferent to the possibility of life, is to step onto a stage larger than we have ever imagined. It is to confront reality with a mix of awe and ambition. The combination is intoxicating. The nervous energy, the adrenaline of potential discovery, the humility before the unknown, it is the crucible in which human greatness is forged. It is terrifying, yes, but the alternative, complacency, ignorance, stagnation, is far worse. Every step we take now, every decision, every launch, every theory, every observation is part of a continuum. It is part of the story that will define humanity for generations. We are the first to see, the first to wonder, the first to confront the possibility that intelligence exists beyond the pale of our tiny blue planet. And with that privilege comes responsibility. Responsibility to act wisely, responsibly, and courageously, to ensure that the attempt is not wasted, that our effort, our striving, our curiosity leaves a mark, a trace, a testament to what we were capable of when faced with the extraordinary. So yes, I am freaking out, but I am not paralyzed. Fear is a motivator, not a prison. The unknown is a challenge, not a threat. Every calculation brings clarity. Every observation brings understanding. Every discussion, every debate, every brainstorm is progress. We are alive at a moment when the universe is demonstrating, in no uncertain terms, that there is more than we have ever dared to imagine. And that demonstration demands a response, an awakening, a mobilization of intellect, creativity, courage, and willpower. And so, we reach forward. We launch probes. We analyze data. We refine instruments. We gather minds. We challenge assumptions. We dream bigger. We organize faster. We learn to cooperate on scales we never imagined necessary. Every act is an affirmation. We exist, we matter, we attempt, we strive, and we hope, because hope is not optional in the face of a vast, indifferent cosmos. Hope is what turns observation into action, curiosity into discovery, and fear into courage. If there is anyone out there listening or watching, I want them to see that we tried, that we didn't just hide in the cave, comfortable in the illusion of safety and centrality. We came out, we reached, we attempted. And in that attempt lies the essence of who we are, the defining characteristic of our species, the refusal to remain passive in the face of the unknown. We do not simply exist, we engage. We do not simply survive, we strive. And in that striving, we become more than ants. We become participants in the cosmic narrative. This is the most exciting time to be alive. It is terrifying, yes. It is humbling, yes. It challenges every assumption we have made about our place in the universe, our capabilities, and our potential. But it is far better than the alternative: boredom, stagnation, ignorance. To confront the unknown is to feel alive in a way that no routine can replicate. To reach, to attempt, to calculate, to dream, that is life at its most intense, most meaningful, most human. And the work has only just begun. Every observation, every mission, every calculation is a step forward, a step into understanding, a step into the broader reality that surrounds us. So let's get to work. Let's imagine, let's design, let's build, let's launch, let's calculate, let's observe, let's collaborate, let's question, let's dream. Let's rise to the challenge, for the universe is vast, indifferent, precise, and unforgiving. And yet, in the midst of that immensity, we have discovered the spark of potential, the possibility of understanding, the chance to assert our presence, our intelligence, our creativity. That chance is rare, that chance is fleeting, that chance is ours, and we will not let it pass.